Hello everybody, welcome to Statistics. This is for week 1, and this presentation will cover an introduction and a little bit about Chapter 1, Sampling and Data, Describing, Gathering, and Organizing Data. One of the most important things to recognize is that this brief does not give all of the details. I have more information available on the actual lecture form, and you must do the reading from the textbook to be fully informed. But I'm looking forward to getting started, and I hope you are too. Let's go. First of all, I want to say welcome to everybody to the class. This lecture and subsequent lectures will be made for sections MA300 95 and 96M. I have 2 online sections here. Both of you will be working with exactly the same material. In this presentation, I want to talk a little bit first about what to expect for our assignments, discussion boards, quizzes, and final project, as well as talking a little bit about our open source textbook. Open source meaning free. In any case, I'm looking forward to getting started right here. I'm just going to quickly run through these reminders on these on our background information before we get into the chapter material. First of all, to contact me, I ask that you contact me by my email address, mpeoples@neit.edu. Since I don't have social media and I don't run other types of contact other than my weekly office hours, I ask that you please contact me primarily through my email, either on Canvas or in the student email system. Recorded lectures are posted by Monday of each week. I should have lectures posted for you every week anyways that I've already made, but these are important to note that by Monday you should have a new presentation made. I do conduct live office hours. I scheduled them for Friday nights from 7 to 8 p.m. each week, but I can actually make office hours using a lot of using the Zoom chat and Zoom conferencing feature. You'll find the link in the Canvas course, and I will schedule at a time that could be mutually beneficial to us. So please, contact me if you need some help. We'll schedule a good time to get together, and we'll walk through the material together so that you have a better understanding. But again, you need to contact me first. I can't guess at a good time that's good for you. The required textbook that we will be using is called Introductory Statistics by Alowski and Dean, first edition. It is accessed by going to the website openstacks.org, and this is a great deal. The textbook itself is free. So if you have questions about where to find any of the information, please let me know. However, I've placed the link for the textbook on the home page and on the subsequent links inside of each of our Canvas modules. You should be using a scientific calculator and a notebook that are required, but it is also required that you use Microsoft Excel. This screen says Microsoft 2013, but really I recommend you get the latest version, which you can find through NEIT IT support. Our grading will consist of online chapter assignments. There's 1 for each chapter. 9 chapters, by the way. 4 online quizzes given in even weeks. 5 discussion boards given in odd-numbered weeks, including this week. A lecture participation, which is a weekly lecture form. That's what you're watching right now, the video that goes with it. And then finally, a final project due in week 10. It will have its own separate brief. Participation is graded by the means of responding to these graded survey forms in which the videos reside. Please make sure that you at least respond to these by Friday of each week. My weekly attendance will be entered by Friday, and you have to be active in the course. Being active means that you've done one of these weekly assignments, the online chapter assignment, a quiz or a discussion board, or responded to the lecture participation by Friday of that week. If I don't see your name on one of those things, you will be absent for that week. So what's due by this week? By Friday, you should have watched the introduction lecture, Lecture 0, and completed this Chapter 1 video lecture and the response form Lec 1. Lec stands for lecture. I will take attendance based on your activity by Friday at midnight. By Tuesdays following that day, you should have completed the discussion board and the chapter assignment. And in this week, our focus is on statistics literacy. Notice that for all the other weeks, the lecture 0 is not due, only the lecture for that week. So it's a little bit shorter, slightly, for the other weeks. Week 1's sort of a busy one for us. So we're going to talk about basic terminology in Chapter 1, and this is where we start our Chapter 1 material. What are we going to talk about? Well, we want to talk about what is statistics. Are there different kinds of statistics? Populations and samples. What do those things mean? Statistics is, well, we hear statistics used in many different ways. The word statistics means things like means and medians and averages, standard deviations, or information about people. The course, or the science of statistics, with a capital S, means that we're going to actually look at how we analyze and deal with data. What conclusions can we draw about data? What can we say about it? Descriptive statistics is where we start. Descriptive statistics are the kind of statistics that describe a situation. Descriptive statistics include things like means, include things like tables. Later, we're going to use those descriptive statistics to support something we call statistical inference, which is how do we come to a conclusion about data, about a population, based on samples? How do we infer something about a population based on what we've learned from a sample? And so populations and samples are very important. A population, of course, is being the entire collection of all of the places where the information, where the data is coming from. A sample is a subset of that population. So if I'm interested in all United States adults' heights, I'm talking about the entire population of the United States. Whereas if I go through and I found a sample of 1,000 adults and I look at their height, I'm looking at a sample of that population. One of the big differences we note about populations and samples is the information that we get from them. When we talk about a population, the information that we get, the measurement of some characteristic of a population, we call it a parameter. On the other hand, when we talk about a statistic, we're talking about some measurement that describes the sample. If I go and I'm interested in the heights of all United States males, I'm looking at the parameter height, because that height describes something about the population. If I go through and I find the mean height of 100 United States males, I have just found a statistic. That height, that mean height of my sample, is my statistic. Here's another example. The Gallup Corporation collected data from 1,013 adults in the United States, and the results showed that 66% of the respondents worried about identity theft. Well, the population consists of all adults in the United States. We didn't talk to all United States adults, but that is the population we're interested in. The parameter is the percentage that are actually worried about data theft. Well, if the sample consisted of 1,013 adults, the statistic was that 66% of those respondents were worried about identity theft. And the objective is to use this sample as a basis for drawing conclusions about the entire population. Well, it's important to understand data, and that's one of the main focuses of this particular unit. In Chapter 1, we talk about data including variables, which is a characteristic of interest for a person or a thing in a population. If I go through and I take a survey of U.S. adult males, I might collect not only information about their height, but their weight, their shoe size, their hair color, their eye color, and any other number of characteristics I care to name. In that survey, if I'm interested in height, the variable for that interest is height. Data itself consists of the collections of the observations, the measurements, genders, or survey responses that we find. When we say a mean, we're talking about a measurement of the center of that data. If I say the mean height of 1,000 males that I go through and sample is 5 foot 8 inches, well, that is a mean. That is a measure of the center. Not everybody is 5 foot 8 inches. Clearly, there are males who will be much taller and males who will be much shorter. But the mean is the middle. Finally, a proportion is a fraction or a percentage of a data with a relevant characteristic. When we talked about our Gallup statistics and we found that 66% of our respondents were worried about identity theft, that 66% represented a proportion or a fraction of the data gathered from our sample. Gathering data, we were interested in looking at classifying the kind of data that we actually have. Well, there are two types. Data can be quantitative, which is numerical data, or qualitative, that is categorical data. The difference is this. In quantitative data, we're talking about numbers, things that we can do meaningful math with. Measurements about height are an example of a quantitative kind of piece of data. On the other hand, qualitative data talks about data that cannot be given in number form. If we talk about how we categorize animals as birds, insects, fish, amphibians, reptiles, or mammals, right? Those are categories. These kind of categories cannot be we can't do anything more meaningful than to count certain types of data that might fall into those categories. That's different, right? Qualitative data might include things like hair color, eye color, favorite ice cream. Quantitative data might include height, weight, shoe size, perhaps even an IQ score or a test score. We further divide quantitative data into two different types. Discrete data is the kind of data that only takes on a particular distinct values. In the video here, if you get a chance to check it out, about old Lucy and Lucille Ball here, they're on a little assembly line here where they're packing chocolates. Well, it's a funny scene where the chocolates start going faster and faster, and eventually you can't see how fast the chocolates are going across the conveyor belt, and it almost looks like it's going continuously. Well, continuous data are data that can take on any values. If I say Lucy packs 100 chocolates, she's packing whole chocolates, not halves, not thirds, not some percentage, right? Whole chocolates. Continuous, we might talk about the weights of those packages. The weights themselves could be on a continuous scale. One box might weigh 1.05 pounds, where another box could weigh 0.95 pounds. You can divide that weight into decimals. If we further classify data, we can talk about qualitative versus quantitative, but quantitative is further divided into discrete and continuous. They're different types of the same category of data, quantitative, but it's a good way of thinking about where we classify our data when we talk about it. So I've got a good question for you. Why do we care where our data comes from? Well, clearly we want to know, because I've heard this term before when I was learning statistics, GIGO. If you've never heard that acronym before, it stands for garbage in, garbage out. Garbage in, garbage out means that if you start out with some crappy data that does not describe your population very well, you're going to get crappy statistics. Garbage in, garbage out. So we're very interested in making sure that our data fairly reflects the population that we're talking about. Well, how do we do that? Well, there are many different ways, and it depends on the type of sampling that we use. The most basic kind of sampling we know is called random sampling. Random sampling is a simple random sample in which every member of the population has an equal chance of being selected, but we only randomly select elements from that. However, that's not always the best way of going about sampling. Surprisingly, we might be interested in other methods. If we have items coming off of an assembly line, we're not going to choose every item to test because we might destroy all of those items coming off the assembly line, but we might test every 25th item coming off of that assembly line for quality, right? That's called a systematic sample. We also sample in other ways. If we're interested in making sure that we're covering a complete geographic region, we might use cluster sampling, in which we go get random samples from geographic clusters in a certain part of the state. If we're interested in doing population or doing a political opinion study, and we're interested in finding political opinions from across the state of Rhode Island, well, a simple random sample might get more respondents in Providence than in Coventry than in Newport. Well, in a cluster sample, we go out and we find 10 respondents in Newport, 10 respondents in Providence, 10 respondents in Cranston, 10 respondents in Coventry, 10 respondents in Westerly, and then we go and we find those respondents and sample them. That's a cluster sample. Stratified sample does the same thing except for characteristics. We might be interested in getting a good representation in terms of men versus women, or in terms of people who come from different socioeconomic strata. Finally, a sample of convenience, not a very good sample, but it might just be convenient to ask the first 10 people you know about their opinion about something. That's called a convenience sample. We also discuss something called levels of measurement. And if we talk about any particular piece of data, we might be interested in characterizing it according to its level of measurement. A level of measurement talks about things like, is it a name? Is it something that we can rank? Is it an interval or is it ratio? Nominal data are data that consists of names, things that we can't really do any meaningful math whatsoever, right? If we have 10 students and we look at their names, right, there's going to be different. If we say there are, in this class, 20 people, and out of those 20 people, 11 are female and 9 are male, well, those qualifications, male, female, are nominal. Ordinal data goes a step further, and that becomes the kind of data that we can order. So it's nominal plus the fact that we can put it in some sort of logical order. For example, if we talk about movie rankings, a movie that gets a ranking of 5 tomatoes is going to be different than a ranking that has 1 tomato from our good source Rotten Tomatoes. Or if we have a hotel that's being ranked by stars, right? 5-star restaurant is better than a 2-star restaurant. Those are data that can be placed in order. Grades, A, B, C, D, and F, are also ordinal. Interval data goes a step further than ordinal data. Interval data is typically numerical data, but it really can only be ordered in terms of their differences. For example, temperatures on the Fahrenheit scale. If somebody tells you that it is going to be 0 degrees Fahrenheit out tomorrow, well, and then we look at the next day going to be 10 degrees Fahrenheit. Well, the only thing that matters to us is that 10-degree difference between the two temperatures. We're not saying it's 10 times as warm as it was when it's 10 degrees out versus 0 degrees out. Ratio data is the highest mathematical level of the data. A piece of data, which is a number, could be a name, it could be ordered, and the interval is important, but also if it's ratio data, it's also important that we can divide. If we say that, for example, one runner took 2 hours to complete a marathon course, whereas another one took an hour, the one runner that took an hour went twice as fast as the one that went 2 hours, right? The ratio is important. Finally, we're interested in how we organize that data, and one way that we are interested in dealing with data is tables. Well, it's very important that we are able to organize data and summarize it by constructing a table, not that kind of table. But one of the most basic ways that we organize data is something called a frequency table. One column lists the categories of the data, the other column lists the frequency of each of those categories and the number of data values in that category. Here's an example. Let's consider the list of 25 grades from a recent test. Now, if we have a lot of these grades and we're just looking at the table and it's a small group, well, we can get sort of a feel for that. But if we really want to tell the story of what this data represents, we put it in a table. Our frequency tables tells us that there were 4 A's, 7 B's, 9 C's, 3 D's, and 2 F's. Well, this is an organization of the data, and it tells us that, well, clearly C's and B's were more popular grades than A's and D's or F's. A relative frequency table is going to tell us the proportion or percentage of the data that falls into a category. If I take 4 out of these 25 pieces of data and divide, I'm going to get 0.16. I represent the relative frequency as 0.16. We also sometimes write it as 16%, but be very careful of the way instructions are given in the assignment here. Typically, I like the decimal form rather than the percentage form. Right, the percentage form right here would be written as 16%, right? But unless I say give me the percent, my relative frequency is going to be given as a decimal. It gets even more interesting when we just have a mass of numbers. We have this table that consists of gallons of fizzy cola syrup sold by 50 associates in 1 month. Just looking at the table, it's kind of confusing. Well, rather than just dealing with the table, what we do is we organize it. We say, well, 2 employees only sold 80 to 89.9, and 6 sold from 90 to 99.9, 10, 100 to 109.9 gallons, and so on down the list. Well, this is exactly what our frequency table tells us, that most employees sold somewhere between 100 and 119.9 gallons. That's interesting, but so is the relative frequency, which I've taken each number out and divided. One other number that sometimes interests us, especially in these kinds of categories where the differences are numerical, is what we call a cumulative frequency. A cumulative frequency starts with the lowest category, and we see that those two match. But then we say, well, from 90 to 99, we say 16%. Well, that is 0.4 plus 12, right? 0.404 plus 0.12. We're accumulating an amount. Right here, we're taking our category above 0.16 and adding the 0.20 to get 0.36 and so on. So this might be helpful in answering a question that says, well, what percentage of employees sold less than 110 gallons? Well, we could say then 36%, or a ratio of 0.36 would be the appropriate answer. Okay, well that takes us through a lot of the material right here. Don't forget that the chapter assignment itself is due by Tuesday, as well as discussion board 1. Chapter 2 will be covered in week 2. I look forward to giving our video then. Good luck and have a great week, everybody.